Hello everyone, so in this video we are going to solve a question of LeetCode, that is Palindrome Linked List. So let's start with the problem statement. Given the head of a simply linked list, written true if it is a palindrome. So in this question we have given a linked list and we need to find out whether the given linked list is palindromic or not, right? So let's quickly see with an example. So let's say we have given a linked list that is 1, 2, 3, 2 and 1, right? So let's say this is a linked list given to us and we need to find out whether this linked list is palindromic or not, right? So the basic approach which we do to find out whether the linked list is palindromic or not, so what can we say is, after observing that this one and this one, right, the starting and the ending point is equal, then similarly this and this are equal and this is equal, right? So we can easily see this, these values are equal, it means this is a palindromic linked list, right? So let's see how can we approach this question. So if we carefully observe the linked list, we can see few things, right? Let's say this is the middle point of the linked list and this is the left part and this is the right part, right? So if we observe the left and the right part, so we can clearly see this left part is the reversed order of this right part, right? Similarly this right part is the reversed order of the left part. So what can we do is we can reverse any of the order so that both the orders will be matched, right? So let's say if we reverse the right order, right, so if we just reverse the right part, so this will become 1 and 2, right? Now this 1 and 2 is equal to the left part, right? So in this case if both are equal, right, if both are equal then we can return true, right? Else in this case or in the other case we can return false if these parts are not equal, right? So this is the basic approach which we need to code in this solution, right? And the prerequisite to solve this problem is we should know how to reverse a linked list, because we are just reversing a linked list and after that we are just matching the left and the right part, right? And let's quickly see how can we reverse a linked list so that you can get an idea if you do not know how to reverse a linked list, right? So let's say we have given a linked list that is 1, 2 and 3 and we have null, right? So if we try to reverse this linked list, how can we do this? Let's say we initially take two pointers, that is the previous one and let's initialize it with null, right? And let's take a next pointer that is also initialize it null initially, right? And let's say we have head here, right? This is head. Now if we start reversing through the linked list, what can we say is, let's say we point this one to null, right? Because when we reverse this linked list, so this will be pointing in this direction and null will be here, right? So let's say we point this to previous, so that would be null here, right? So let's say let me write the algorithm here. So if we write the algorithm, so let me just type it here. So the first point would be, let's say we write a first point, that is the first one is let's say we take a next in the head next, right? Why we are saving this head next? Because in the further steps we will be changing this head next, right? That is why we need to store it somewhere, right? So let's say we store head next, this is head and this is head next, right? This is head next, so we just point this head next to previous, right? So in previous is null, so we will just remove this and this will be pointing to null, right? So let me write this statement here. So this is the second statement, that is head next is equal to previous, right? Now what we basically need to do is we need to update this head to head next, right? This we need to do. And the second thing we need to do is we need to point, right, we need to point this previous, right? Basically we need to update this previous, because previous is here, right? Previous is here and we need to update this previous to here. Previous will come here and head will come here, right? this head will be coming here and previous will be pointing to this. So let me just write these two statements here. So the third statement is this previous will be now is equal to head, and head will be is equal to head next. So we have changed the head next, but we have also saved this head next pointer to next. So let me just write it here, that is head next, right? So that is next. So I hope these four statements are clear to you. So this is the algorithm to reverse a linked list, right? So to reverse a linked list, we will be writing these four statements. So this is the one part of the solution. Now the second part is, first we will find out the middle of the linked list, and then we will compare both the left and the reversed right part, right? So let's quickly code it up. I hope this approach is clear to you. If you still have any doubt in this approach, feel free to comment it down. I will try to explain it again. Let's move to the coding part. So let's quickly write this reverse function here, right? This is a reverse function. So let's write this reverse function first. So let me write it here. This will be returning a reversed linked list. So let's return linked list node, that is a node of the reverse linked list, and let's name it reverse ll, right? Reverse linked list, and let's call the head of the linked list, so list node head, right? Now what we did is we first initialized two variables, right? We first initialized previous and next. So let me write the same here, that is list node previous is equal to null, and the second one is next, that is also equal to null initially, right? Now the next thing we need to do is we need to run a while loop until head is not null, and let's update, or we can say let's write these four statements here. So the first statement is next is equal to, right, the first statement is next is equal to head next, so this will be head next, right? Now the second statement is this head next, right? This head next will be now pointing to, right, this is the head next will be now pointing to this previous one, right? So let me just write it here, this head next is pointing to previous one, right? Now this previous one will be updated with head, and this head will be equal to head next. So head next is saved in the next, so let's write next here. All right, this is fine, I guess. Let the end just return previous. Why we are returning previous? Because this head will be null, right? This will be null. Let me just explain it here. Let's say this is reversed, so this null will be, let's say this would be previous here, and this head will come here, and this all will be reversed, right? After running this while loop, this all will be reversed and previous will be here. So this would become the head of the reverse linked list, right? So the reverse linked list would be 3, 2, 1 and null, right? So this we will be returning from here, right? So I hope this reverse function is clear to you. Now let's quickly code upper is palindromic function, right? So let's quickly code it up. So let's take list node slow is equal to head, and fast is equal to head. This is the generic approach which we follow to find out the middle point, right? The fast and slow pointer. So let's quickly run a while loop until slow, or we can say fast next and fast next is not null, right? Until these are not null. So let's say this is a linked list given to us, right? This is a linked list given to us. So in this linked list, at the end, this like this initially this fast and slow is here, right? Then slow will come here and fast will come here, right? And then fast will come here and slow will come here, right? So the while loop will stop in this condition when slow is here and fast is here, right? So basically for this flow, we are getting the middle point, right? We are getting the middle point. Now we need to reverse this part. So the head of the reversed part would be this one, right? The right part of the head of the right part would be this one. So this is the slow next, right? This is slow next. So let me just write same here. So before that, let's um, first find the middle point. So slow will be equal to slow next, and fast will be equal to fast next, right? And now let's update slow next with the reversed part. So slow next would be equal to reverse ll slow next, right? So this will just update our linked list with the reversed part, right? So this linked list will be updated with, this would be 1 and this will be 2, right? After reversing, this will be updated with this, right? Now what we basically need to do is we need to check this part, right? We just need to check this part. So let me write the same here. So this slow will be now is equal to slow next. Why we are doing this? Because this slow is here, this is the middle point, but we need to check from here. So we will just update this slow to slow next, right? Now let's run a while loop. Let's run a while loop. So for this while loop, let's run till slow is not null, right? Until the slow is not null, we will run this while loop, and let's say this head is here, right? This head is here and slow is here, right? So we will just run a while loop checking whether these values are equal or not, right? Is 1 and 1 are equal and 2 and 2 are equal, right? And at the end this will go out of the bond, or we can say this would become null. And if this would become null, it means we have completed the iteration of the linked list and our linked list is palindromic. Else it is not a palindromic linked list, so we will return false, right? So let's quickly write these statements here. So if slow value, right, if slow value is does not equal to head value, right, in this case let's return false here, right? Why we are returning false? It means the values are not equal. It means this is not palindromic, right? If this 1 and 1 are not equal, then it is not palindromic, but in this case 1 and 1 both are equal, so it is palindromic, right? So in this case, like else, what we basically need to do is we need to update slow with slow next and head with head next, right? So I hope this is fine. At the end just return true, right? If it's complete the iteration, it means this is palindromic, and yeah, we got the correct answer. So let's quickly run this. Yeah, it's running fine. Let's just submit this. Yeah, it's running fine. So now let's discuss the time and space complexity of our solution. So the time complexity of our solution is bigger of n, because at max we will be traversing through all the n elements, and the space complexity is bigger of 1, that is constant, because we are not using any extra array vector or any data structures. We are just storing the constant pointers here, right? So I hope the approach and solution is clear to you. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. I will see you in the next video.